All right, today we're going to move into chapter 2. And chapter 2 is about modeling distributions of quantitative data. So from here on out, we're only going to talk about things that are quantitative, at least for this rest of the unit. So what I have on here is a dot plot of a random sample of heights of AP Stats students. So let's answer these questions together. The first question says, Ariana is 65 inches tall. What percent of heights are less than, and I want to add or equal to, than 65. And there's a reason for that I'll get to later. So let's go ahead and figure out what percent of heights are less than or equal to 65. So we're going to want to include this 65 here. 1, 2, 3, 4, 5 of them are at least that out of, there's 20 total. Okay, so we'll make that into a percent. I want you to put your height in here, at least your best guess. We are in inches, so make sure you have your height in inches. And then pause the video and fill in which percent of heights are less than or equal to your height. There should not be an S there. All right, so I'm not going to put an answer there for B because, of course, it depends on what your height is. I have now put the data into a histogram for you. So I'd like you to use this histogram to complete the table. You'll need to figure out the frequency, and then the relative frequency, and then something called the cumulative relative frequency. So what I want you to do for now is pause the video, fill in the frequency and the relative frequency, and then we'll talk about cumulative relative frequency here in a minute. So what you'll see on my screen is the frequencies. Remember that the frequency is just the count. So all I've done is I've looked at my histogram, I figured out how tall my bar was, and that would be the frequency. The relative frequency is the percent. When it comes to relative frequencies, it's your choice if you'd like to leave them as a decimal or turn them into a percentage. I'm going to leave mine as a decimal for today, but if you have this as 5%, 15%, that's fine as well. Let's talk about the cumulative relative frequency. Cumulative relative frequency is exactly what it sounds like. It's going to be cumulative as we go down the graph. So the first bar, it's just the first piece of data. So I have 5% of my data here. And then when I get to this bar, I'm going to add everything below it. So I'm going to add my 0.15 to my 0.05. And what this is telling me is that 20% of my data is at this point or lower. Keep going here. We've got 0.65. So 65% of my data is here or lower. 95% of my data is here or lower. And then this would be 100% of my data is here or lower because we're at the top of our graph. Okay? So we're going to use our information from this table to create a cumulative relative frequency graph. So you'll want it to go up to your scale. Now, if you did percentages, you'd want this to say 100. I'm just going to leave mine as 1. I'm just going to put a bar out here at 50% and make my best estimate for where the heights of the graph should be. Okay, so go ahead and fill these in. Make sure that you put your height down here. And just like we talked about before, how the frequency and the relative frequency graphs can have kind of the same axes, that can be the same thing here. You can use your same x-axis for your cumulative relative frequency as well. In a cumulative relative frequency graph, the bars should never go down. So it's cumulative, they should always either stay the same or increase at each point. If you want to figure out the amount of data just in one section, for example, the relative frequency, you can look at the size of the step that it takes to get up here, and that would be how much data is in that specific graph. So this takes a jump of 0.05. That's how much data would be in this section from 75 to 79. Okay. All right, so I am 73 inches tall. That's a real number. I want you to estimate and interpret the percentile that I am at using the graph. So a percentile is exactly what we found here above. It's the amount of data less than or equal to 65. The College Board has changed its mind recently about how they want to interpret percentiles. That's why I had you add the or equal to. They used to say that percentiles are strictly less than, and now they're transitioning to saying that percentiles are less than or equal to. So when we find 73, we want to estimate the percentile that I'm at. Now, could we find my exact percentile using the data that's up here? Yes, we could, but I don't want to do that. I want to estimate. So let's say, for example, we are only given this graph. We need to estimate where I'm at. So 73 is somewhere right here-ish. and it's somewhere kind of in this range. Okay? It's not exactly 75, so I can't say that it's exactly at this 95 percentile, but I will say that it's probably pretty close. Okay? So I'm going to estimate it's slightly less than 95%. Somewhere just under that. 73, I'm sorry, is very close to the 74 that we see here. Okay. So the percentile, we definitely need to use a cumulative relative frequency graph so we can see the cumulative percents. And then that's the graph we want to use. The interpretation means that she is taller than 95% of AP Stats students. And maybe we should say she is as tall as or taller, because we did include that. So when we're estimating the 80th percentile, we're going to look where 80 is. So the 80th percentile is asking a slightly different question than we're asking in Part E. Here I'm asking the 73 inches. Here I'm asking the 80th percentile. So the 80th percentile, the interpretation of that is that 80% of AP Stats students are as tall as or taller than a certain cutoff. Now we don't know what that cutoff is because the information that we're given is the percentile, the percent. We're not given the cutoff. So I need to go back up here, and I don't know exactly where 80% is going to fall, but it's going to be somewhere between 65 and 95. And if I add up here, I'm sorry, I'm looking at the wrong graph. This guy down here, I'm going to actually put my percents on top. It's going to help me a little bit more here. All right, so it's definitely more than 70 because at 70 we've only reached 65%. So it's going to be somewhere between 70 and 75. So maybe let's estimate it to be 73 or 72. Okay, somewhere in that range. Okay, so our as tall as or shorter, because it's less than that height. Okay, as tall as or shorter than 71 inches. Okay. So back up here, our interpretation, I am as tall as or taller because everyone else is shorter than me. But here I've reached, this is my top cutoff for my percentile 71. Okay. All right, let's give some sort of actual name to what a percentile is. Okay, here on the next page. Alrighty, a percentile is defined as the P percentile is interpreted as the value that has P% of the data less than or equal to it. So I'll put a little star here. That cumulative relative frequency graph is going to be really important because the cumulative relative frequency graph shows us the amount of data here or lower, here or lower, here or lower. And that's exactly what a percentile does. We're looking for that value that has P% of the data less than or equal to it. Okay? So what we have here is some of my Chapter 1 geometry quizzes from last year. And here's the results. So we kind of did all over the board. I've put the dot plot on there for you. And I've also put in a number summary. So I've given you lots of information so you don't have to calculate that out. I did give you the standard deviation, so we're going to use that. So what I want you to do is pause the video here and see if you can answer questions A through D. Questions A through D. All right, so I filled in the information here. So there are 3 people who scored equal to or less than Ron. 3 out of 20 is 15% of the people, so Ron is in the 15th percentile. That means that 15% of people did as well as or worse than Ron did on the test. Ron was below the mean. I did calculate out the mean to be 80. He was 15 points below the mean. 15 points is 1.5 standard deviations. So the standard deviation is 10. So 1 standard deviation down is 70 points. He did 65, so that's 1.5 standard deviations below the mean. I used a similar process for Harry. There are 16 out of 20 people did equal to or less than Harry, which means that 80% of people did as well as or worse than Harry did on the test. Harry was above the mean by 8 points. That's 0.8 standard deviations, since the standard deviation is 10. Okay, so let's talk about this thing called a z-score. A z-score is the number of standard deviations above or below the mean. So I want you to think about that for a second and think about how you might calculate a z-score. These numbers here are z-scores. So you can start to think about maybe how you would calculate out that. How I would calculate out my z-score, I would take the value that I'm looking at, for example, 88. I subtracted off the mean to get 8, and then I divided that by the standard deviation. That's how I calculated out the z-score. Okay, so we're going to talk about what that means here in a couple videos. Hermione, she got a 98 on the test. So let's figure out where her z-score is. So Hermione got a 98. Let's subtract off the mean of 80 and divide by the standard deviation, which is 10. So if you get that math in there, it should be 18 divided by 10, which is just 1.8. Okay. The interpretation is also going to be really important here. Hermione scored 1.8 standard deviations above the mean. She is higher than the mean. We're going to talk about why z-scores are important, okay, as well. Okay. Okay, so in the next video, we're going to talk about z-scores just a little bit more intense, about what they mean and how to interpret them. Okay, so stay tuned for the next video.